It's an honor and privilege that Dr. C. Mohan has accepted to be a part of this 5-day online faculty development on blockchain technology. He is one of the most distinguished speakers who has given a lot of talks on blockchain technology across the globe. So, talking about Dr. Mohan, Dr. C. Mohan is currently a distinguished visiting professor at Tsinghua University in China, consultant to Microsoft's data team, and an advisor of the Kerala Blockchain Academy and the Tamil Nadu e-governance agency in India. He retired in June 2020 from being an IBM fellow at the IBM Almaden Research Center in Silicon Valley. He was an IBM researcher for 38.5 years in the database, blockchain, and related areas, impacting numerous IBM and non-IBM products. The research and academic communities and standards, especially with this invention of the well-known Aries family of database locking and recovery algorithms and the presumed abort distributed commit protocol. This IBM, ACM, IEEE fellow has also served as the IBM India Chief Scientist during 2006 to 2009. In addition to receiving the ACM Sigmod Edgar F. Cord Innovation Award in 1996, the VLDB's 10-year Best Paper Award in 1999, and numerous IBM awards, Dr. Mohan was elected to the US and Indian National Academies of Engineering and named an IBM Master Inventor in 1997. This distinguished alumnus of IIT Madras, 1977, received his PhD at the University of Texas at Austin in 1981. He is an inventor of 50 patents. Since 2017, he has been an evangelist of permission blockchains and the myth buster of permissionless blockchain. He has served on the advisory board of IEEE Spectrum and on numerous conference and journal boards. Mohan is a frequent speaker in North America, Europe, and Asia. He has given talks in 43 countries. Sir, it is an honor and privilege to have you associated with our FDP. I give the stage over to you, sir.
Thank you, Bhargavi. Can I get the shared content?
Sir.
Okay, thank you. Good morning, everyone. As was mentioned, I'm speaking from Silicon Valley, so it's around 8:17 p.m. here on Sunday, and it's I guess 9:37 for you. Oh no, 9:48, huh? Yeah, 9:48 for you. And I know there are a couple of people at least registered. I don't see all the registrants showing up. It's number 116 registrants, but I guess that are attending now. But I think 200 are supposed to have registered. Couple of them are from Vellore, which happens to be my hometown. Yeah, I saw there were 2 registrants, and of course, I've been in Bangalore for almost 3 years during my IBM India Chief Scientist tenure. And so it's nice to see people from across India participating at this event. So let me now go to the presentation. I've got a lot of material. Obviously, I don't have as much time to present everything. Let me see. Okay, so it looks good, right? Yeah.
Yes, sir. Yes.
Yeah, okay, wonderful. So if there is any problem, let me know, because the other day when I was giving a presentation, I got disconnected and I wasn't even informed, and I kept talking for a while before I even realized that connected from the network. So you see here the URL at the bottom of the page. That's where the presentation is available, and I also in the chat put this link. If you go to the beginning of the chat, you will see this link. There are other links also shown here. This link that you see, unfortunately, is not working right now. Facebook guys seem to have some trouble. This is a note in Facebook, but even non-Facebook people should be able to access it. It's got lots of material that you'll find very useful. There is also a paper that is about 8 pages long that I presented last year at the ACM SIGMOD conference. So that's this URL. And then there's a video associated with that presentation, which was given in Amsterdam, as you see at the top. It was a keynote in July last year. And there are also slides available. So in general, what you'll find is that whenever I post slides, if you look at them in slideshow mode, you will see the slides that I actually showed. But if you go into edit mode in PowerPoint, then you will see a lot more slides because a whole bunch of slides are in the hidden state. So slideshow mode will show you what you see in the video. And if you go into edit mode, you'll see lots of other slides which will give you more information and things like that. What else do I want to tell you? I guess that's about it. You will see that even with the same set of slides, I'll say different things at different times. So it's still worth going and listening to my past talks in the form of videos or interviews and such, or panel discussions. There's quite a bit of material, and as was mentioned when Bhargavi read my biodata, I've become like a passionate evangelist for permissionless blockchains, also called blockchains or consortium blockchains. In contrast to, sorry, I become an evangelist for permissioned blockchains, which are all private blockchains or consortium blockchains. I am not at all in favor of permissionless or public blockchains, as you will find most people discussing them. Things like Bitcoin and Ethereum and so on. If I had all the time in the world, these are the top I will cover. And there are presentations where I've covered more than what I'll be able to do today because I had 2 hours and 3 hours and such time spans available. But essentially, the idea is to tell you about why I feel strongly that permissioned blockchains or the private blockchains are the most useful ones, and the rest are all of more esoteric interest. I'll give you some background on how these things came about and how they are being enhanced, what the problems are with the fact that there are so many systems around in the absence of standards and things like that. Some discussion about applications and also not just prototypes being built, but in fact, a lot of production deployments being done across the globe, and therefore to an extent that are happening in India too. And then I'll talk about some of the technical details of these systems in general, as well as specifically with respect to specific systems. What you see in green here are some of the systems that I'll mention. The one in red is a special case. This is what Facebook guys proposed. It's a combination of a public and a private blockchain. And then I'll also talk about some of the open areas for research and product development and things like that. As I said, there is this 8-page paper that I wrote in the context of the keynote I gave at ACM SIGMOD last year. It's pretty easy to read. It doesn't have any fancy algorithms and all that, but it'll put in text form some of the arguments that I'll be making over here. And it has also got about 70 references with links to online versions of those papers, research papers, as well as white papers and system documentation and so on. So the whole thing got going seriously about 10 years ago when somebody by the name of Satoshi Nakamoto, this is not a real person, it's actually a pen name that was used by one person or a group of people who wrote a paper on a system called Bitcoin. This system had the philosophy that any number of people across the globe with their identity can participate in this Bitcoin network. And the only thing it supported was the ability for people to transfer this new kind of currency, cryptocurrency called Bitcoin, that was created by the people who came up with this system. The way the money gets created is also bizarre. By wasting a lot of energy by doing some computations, certain people get the privilege of being able to play a role in deciding which of the submitted transactions get executed. And there is a competition that the so-called miners participate in order for them to get this opportunity to be the one or ones that get to create a new block of transactions and attach it to the existing chain of blocks of transactions that already exist. If you manage to win this competition and hence get the permission to add a new block of transactions, you as the winning miner get some reward. And that's how Bitcoin gets created. And also the people who have submitted the transactions which got included in that block also pay a fee. So there is this notion of reward and fees and all this that goes with it. And in order to prevent people doing bad things, because you don't know the identity of people, and hence under the anonymous way of doing business in this network, people might misbehave, try to even rewrite history and so on. The original designers of Bitcoin notion called proof of work, which is essentially people who want to participate as miners solve a math problem. And that's time consuming. The idea being that if people are made to do a lot of work before they get the privilege of being allowed to add a new block of transactions, maybe the bad people will not want to participate in this kind of network, and hence you can in some fashion weed out bad characters by making them go through this procedure called mining, which is solving this map problem. But overall, ways of doing transaction processing, this is an extremely expensive way of doing things, which results in really bad performance, 7 transactions per second. And for each transaction's outcome to be determined, it can take 10 minutes or even more, which is all bizarre compared to even 35 years ago when people wanted sub-second response time for transactions and thousands of transactions to be executed in any second, right? And of course, since the time of 35 years ago, now hundreds of thousands of transactions get executed per second in traditional transaction processing systems like IBM mainframe products or Oracle, DB, CICS, IMS, and so on. Pre-relational systems as well as post-relational systems or application servers like WebSphere and others, BEA's product and so on. But because people are allowed to participate in this network without having to reveal their identity and such, this has also become, as a result, a way for people to transfer money illegally and also indulge in illegal activities like drug selling and prostitution and things like that. So this Bitcoin concept and the associated network has enabled all sorts of illegal things to become possible without people's identity being known. And also the notion of paying for a transaction to be executed and trying to influence which transactions get included in a block of transactions for them to even be seriously considered to be executed causes all sorts of weirdness to come about. This is not the traditional way in which transaction processing systems schedule transactions. They do it based on priorities and things like that, not based on who is offering how much money and things like that. So of what I consider to be greed-based way of doing things is also something that I don't appreciate at all, as a good thing that is part and parcel of these permissionless blockchain systems. But because it got invented a while ago and people talk about also like, they provide trust in a completely trustless environment, and they allow for participants who don't know each other to still do things in a trusted way. A lot of that is hype rather than reality, actually. But in any case, since Bitcoin, other systems have been developing Ethereum, for instance, which we'll talk about later. And as a result of the momentum that got built up with Bitcoin, lots of institutions across the globe, little ones to big ones, private companies to government entities, and so on, are all working on various aspects of this. Universities and industrial research establishments, startups right here in Silicon Valley, or big companies like IBM and Oracle and AWS and Microsoft and so on. They're all working on various aspects. Theoreticians as well as very practically oriented people are addressing the kinds of topics that I mentioned here. In contrast, public blockchains, what I'm focused on, and I feel the whole world should be focusing on a lot more than it's doing, is the so-called permissioned or private blockchain systems. These are the systems where, by definition, a network gets formed in order to deal with a certain use case scenario. You don't put into a single network all sorts of random, totally unrelated kinds of activities, as is the case with the typical permissionless blockchain system, where there will be one single network in which all sorts of use cases will get implemented, which also causes a lot of performance problems, scalability problems, and so on. Whereas in the case of a permissioned blockchain system, first of all, the participants should have a reason to be part of the network. Otherwise, they don't get admitted to that. The reason being, they are participating in the sense of organizations participating in such a network because they are part of the business process, or it's individuals within those organizations who play different roles, who as a result have a reason to be part of the network. Only such people and such organizations will be allowed to become legitimate participants in such a network. By definition, they have to reveal their identities and they have to authenticate themselves. They are authorized to do only certain things and so on. This is no different from in traditional database systems or any other systems for that matter. You have a user identity and you have to log in and you have to prove the relationship between this user identity and the real world identity. And also, based on the role you play in your organization or as an individual with no organizational association, you might be like, I'm a consultant to Microsoft. So Mohan is a consultant to Microsoft. In that capacity, I get to do certain things, or I'm permitted to do certain things while I am on the Microsoft network. Things like that play a role in deciding who gets to do what, which transactions can be executed by whom, and so on. This is no different from in traditional database systems, people being authorized to only read a table's contents versus some other people being allowed to not only read the contents, but also modify the contents. Because of this set of restrictions that are placed, the bad behavior that I talked about that people might indulge in, the so-called Byzantine behavior that is worried about a lot in the permissionless blockchain network, is a lot less of a problem in the permissioned blockchain systems. Because only few people are allowed to be part of the network because they have a role to play, by definition, these systems are a lot more scalable than this mishmash of people and organizations being put together in a single network, as is the case with the permissionless one. It's also the case that in the permissionless one, simultaneously, multiple people might win that competition to be permitted to add a new actions, which results in what was a linear chain of blocks, 1 through n, suddenly having branches, because n plus 1 and n+1 prime and n+1 double prime might all be alternate blocks that different winners of this competition are being allowed to add, which is like, conflicting versions of software being simultaneously produced. People who start with the same base and they are making changes to the same module, and now you have conflicts in a software engineering kind of sense. So these are also aspects, if you like, of the permissionless network. Whereas in a the network, typically, they don't allow these ambiguous situations to show up. And that's why I talk about deterministic behavior, no forking, and the linear blockchain. At any given time, only one person will be allowed to add a new block. So there is only like a single path. There isn't like a tree of different paths that might come about in the permissionless network, which causes additional problems that I won't get into over here. And also, I'm not in favor of cryptocurrencies. They have lots of problems, and the typical permission blockchain system, except for Enterprise Ethereum Alliance based systems, don't have built-in cryptocurrencies. If you want, you can implement it on top, but generally they are not trying to replace fiat currencies like rupees and dollars and euros with some, computer-generated currency with no real-world, goods and services being associated with it. Let me go on. So, mental model that I want you guys to have is one where you have a business process, as you see in the picture, where there are organizations, which are the nodes, which are the interior nodes, and then you have people within these organizations, which are the leaf nodes, typically, who are the people within those organizations who have certain roles to play. A particular business process deals with a certain use case. And so a particular blockchain network, private blockchain network, will be for the purpose of executing transactions related to that use case. Generally, these organizations and people within them collectively manage a certain set of assets. These assets could be purely logical assets like music recordings, which are digital assets, or they could be managing digital information about physical assets, real world assets like packages and food ingredients or car components and things like that. Okay. And what are the transactions that you execute in such an environment? These relate to the assets undergoing some state changes. Component gets included in bigger component. Hello? Did somebody want to tell me something? Everything is okay, right?
Yes, sir. Please go ahead, sir.
Okay. Or the asset could be undergoing ownership transfer. I sold Bhargavi a diamond. So the ownership of this particular instance of the diamond data type gets changed from Mohan to Bhargavi. Okay. And then Bhargavi might sell it to Asha and so on. So these are the transactions that are being executed. And the smart contracts that you'll hear about, think of them like traditional database applications, but they have a special role to play in the case of a blockchain kind of network where the set of applications that are in execution that in the logic of these transactions that I mentioned are collectively agreed upon. They embody the rules of engagement that relate to these multiple organizations and the people within them are transacting these state changes and ownership changes. In the case of a diamond, the diamond gets mined in its raw form, then it gets polished, then it gets split into smaller diamonds. These are all state changes, right? So the smart contracts are more systematic ways of codifying the rules of engagement amongst these different participants. And the ledger, nothing but like a bank ledger, which keeps track of what transactions got executed, by whom, what conditions, who all agreed for a transaction to be executed, and so on. It's this systematic way of tracking what happened, when it happened, and under what conditions, doing it in a way where once you record this kind of information, it cannot be tampered with in an undetected fashion. That's what makes blockchain way of doing business a lot more sophisticated than the traditional way in which transaction processing systems, workflow systems, and business process systems have done similar kinds of things. So think of this blockchain as a shared, replicated, and permission ledger, like a bank ledger. In a bank ledger, you never go and change old entries. Even if an entry was created erroneously, like I deposited $1,000, but it got recorded as $100, and I go complain to the bank, hey, I received my statement, I noticed you got $100 there, but look at my receipt, it shows I deposited $1,000. Then they'll put a new entry saying, this is a correction to this original entry, because they want to keep track of all the events that happened in the exact order in which they happened and not do in-place correction. Okay, so this is why the ledger or the blockchain data structure itself is append-only data structure. Okay, you only add new information. You don't go modify the existing information. This is not to say that you still don't have a separate database in which you are keeping changes and ownership transfers and all that. And that database itself can be a traditional database system in which in-place update is being done. But it's a separate data structure called the blockchain, which was an invention of the original Bitcoin designers. This notion that this data structure blockchain, which is managed in a very specific way, where if anybody goes and tampers because of the use of hashing and Merkle trees and so on, such illegal tamperings can be detected. This relates to also how cryptographic protocols work and so on. So I won't go into more of the details of this. I'm assuming other speakers will get into all that. So just to contrast, the doing on the left in an import-export scenario, the blockchain way of doing the same thing is on the right. What is different about these two pictures? In the left-hand side one, each of the participants has its own database system, has its own set of programs. Oracle, SAP, but each of the nodes in this network, the exporter, the importer, the carrier, terminal, and so on, they all have their own persistent databases in which they are tracking various things that are happening as part of goods being exported and being received and transferred and so on. There is no single source of truth. Even when Federal Express gives you a tracking number, don't think that you get everything. They only expose to you using the tracking number certain pieces of information. Where is the package at this point and so on? Who accepted the package and so on? But there's a lot more information that's in their private databases that you don't have access to. And as a result, still certain fraudulent things can happen. You are transporting some perishable goods in a truck. The air conditioner in the truck fails, so the temperature is not what it should have been. And as a result, maybe it's a medication, right? It gets spoiled. And then somebody takes that medication and dies. Later on, the truck guy might actually tamper with the temperature recording to claim that the temperature in the truck was fine. It's somebody else who caused the problem. And these are hard to detect in the traditional way of doing things, as in the left-hand side. There's also a lot of delay involved in trying to track what the status of something that you are interested in is, because you have to inquire in multiple systems to find out where is at any given time. Even the notion of tracking number and all that is a modern day concept. In the good old days, even that was not there. Lots of paper and pencil way of doing things is still the case with the left-hand side way of doing things. Whereas in the right-hand side, everybody uses the same set of, and they use more or less the same set of database systems based on use of a particular blockchain system. And the logic that's embodied in those application programs that are being executed in the different nodes is collectively agreed upon logic. And as a result, there isn't any ambiguity and things like that. And it's much more systematic. And there is essentially a single database which is replicated, completely replicated in all the nodes that are participants in this network. So it is a much more methodical way of doing transitions. And there are also rules like, a woman and a man can get married only if the priest asks both of them, are you willing to marry the other person? Kind of mutual agreement being looked into. And only when there is agreement, the marriage being consummated. There are such songs and dances go through in order to, in the blockchain way of doing business, decide when it is okay for a transaction to be executed. Based on each transaction type, a subset of the nodes in the network might have to be consulted to get their agreement before you actually execute. This way of systematically doing things and also making use of private key, public key, that make things this way different from the old way on the left-hand side. You might ask, I've talked about a network. Network gets created by some people. Who are these people? And who gets to decide who can be a participant in such a network? So here are some options shown. It could be like IBM says, hey, if you want to be a supplier to me, I'm the boss who is going to create a network. And based on certain acceptance criteria, I will tell people, you can apply to me. And based on my evaluation of your credentials and past work, recommendation, this, that, I might allow you to become part of my supplier network. If you get lost, you don't qualify. That could be one way in which this a certain use case scenario gets created and the permissioning and all that is managed by the big boss. There could be others where multiple organizations get together, like for instance, as is IBM and Maersk, world's largest shipping company, jointly decided to create a network and be the ones who determine who else gets admitted to such a network. In this kind of a network, one good thing is that if you are noticed to misbehave, then the system can easily deal with it by kicking you out of the network and not letting you be a participant anymore. Such a thing is a very hard thing to in a permissionless network. There are other possibilities also here. A network could be formed only for, as it says, risk blocks, or like even more general kind of network, like a business ecosystem, where car life cycle network, which consists of different industry people to be part of a single network and so on. So there are various possibilities here. You might ask me, what's the current state of affairs? While the permissionless networks have been around for about a decade, the permissioned ones are of more recent vintage. They've been around for about 3 to 4 years. Yeah, there is a lot more hype about the permissionless network. Generally, when people say blockchain, without even bothering to clarify, they'll be assuming they are referring to a permissionless blockchain. But in fact, you should question them and ask them, why do you think it's appropriate to use a permissionless blockchain in this particular use case, when in fact, people's identities and all that are extremely important. I don't want to permit illegal things to be done. And I also want to be able to nail people if they do something bad. And I want to be able to go, file a lawsuit and all that. If I have only an address as the representation of an individual, I can't do anything with it. Nobody is going to pay attention to me if or somebody ripped me off, and so on. So, but there are people who have become very religious about this whole permissionless network. It's like people, having gurus and believing everything that the guru says, kind of thing. There's all sorts of bad stuff that goes on in this case. This is by even, researchers as well as startups and so on. There's a lot of hyping going on because to make a fast buck and things like that. There was also, various countries treating cryptocurrencies differently. China, for instance, said cryptocurrencies are not going to be allowed. While there is value for digital representation of currencies, they better be representing fiat currencies like the Chinese yuan. So they have got something that's about to be released or has just been released called DCEP. But there are other countries where they are encouraging cryptocurrencies, just like in the good old days with regular, types of businesses and so on. There are tax havens, right? Mauritius and some countries in the Caribbean and so on, which allowed all sorts of hanky. They're now getting into this bandwagon of cryptocurrencies and allowing, because they don't care, I suppose, enough, all sorts of illegal things to be done, money laundering and all that to be done. Lots of governments don't want to permit this. So the Indian government was not actually in favor of cryptocurrencies, and there's been lots of discussions about this in the Indian context. So in terms of the systems that have come about, I say that it's as if, you are back 35 years ago when relational database systems had just come out. A few products were released at that time, but you as the user of such products was left to your own devices to figure out these things. Because there weren't enough tools and all that made it easier for the mere mortals to be able to use those systems. You had to be very knowledgeable to use them. We are in a similar state with respect to permission blockchains. You have to know quite a bit because they are still in their infancy. Just like relational systems in the last 3.5 decades have had various enhancements made to them, both with respect to functionality and with respect to their usability. A lot more such things need to be done in the context of permission blockchains. And so hence, there is a lot of scope for innovation, both in terms of, people coming out with PhD theses, master's theses, research papers, as well as products being developed, as well as use cases being developed, which take advantage of certain features, for more use cases to be developed using these systems, additional functionality that needs to be incorporated in them. So that's what I mean by many interesting issues remain to be solved and new tools to be built. Just like you have with database systems, the transaction processing council benchmarks, which are loved when they got developed about 30 years ago, and they have been since then enhanced with new kinds of workloads being covered by these benchmarks, TPC-B, TPC-C, TPC-D, TPC-H, and things like that, or TPC-W. There is need for benchmarks in the context of blockchain systems to be developed. There are baby efforts that have gone on here. There's a lot more that needs to be done. The same sort of thing relates to standard. In the good old days, when originally the relational systems came out, they were in my research lab. By the way, SQL and the relational data model came out of my research lab. I was part of which Ted Cord was a member. He is the father of relational databases, and he got the Turing Award for that. The SQL language was developed by my colleague Don Chamberlain and Ray Boyle. So while my contemporaries were doing that before I joined IBM, about 40 years ago, people at Berkeley, University of California at Berkeley, were developing a competing system called but they developed their own language called Quell, Q-U-E-L. The underlying conceptual model for these two systems, in my lab, it was called System R, the system that they developed, and it was Ingress. The underlying conceptual model was model. In Berkeley, it was Quell. In IBM San Jose Research Lab, it was SQL. Of course, later, the standards body chose as the language, and so Quell sort of disappeared, although it lived on for a while in the research context, but not in a product context, seriously. PostgreSQL is an evolved version of the original Ingress system with additional functionality and all that. But in the case of the permission blockchain systems, not only are the different, but for example, Hyperledger Fabric and Hyperledger Sawtooth versus R3 Corda versus the JP Morgan system, Quorum. But even the underlying conceptual models are different across these systems. And hence, it's even more problematic to think about portability of your smart contract, moving your use case from one system to another system, and so on. You have a lot more headaches. The only saving grace is that in the context of these permission blockchain systems, the number of such systems is much smaller compared to, for instance, the chaos you have with NoSQL systems, where there are way too many of those systems, each one with its own variation on the APIs and even the underlying conceptual models. So at least it's not as chaotic as the NoSQL systems or the big data systems. But one saving grace is, just like when Quell and SQL existed, SQL won out because IBM was behind it. It, in fact, initially was a de facto standard, and later it became actually a standard. This is no different from Java and such languages becoming more popular than other programming languages because some big companies. So in that sense, Hyperledger Fabric, which IBM had a serious role in creating it and making it get adopted widely and open sourcing it and forming a consortium around it in the Linux Foundation, which is called Hyperledger, umbrella of which Fabric has been enhanced since its birth inside IBM originally. This has become like a de facto standard now. There are lots of companies which offer blockchain as a service based on Hyperledger Fabric. So it is in many ways safe for you to go with Hyperledger Fabric because, as you will see soon, lots of companies offer cloud-based implementations of the Fabric. Just like you have infrastructure as a service, platform as a service, now you have this new kind of thing called blockchain as a service. It is also the case that compared to relational, in the case of blockchains, the permission blockchains have gone from their initial development to people doing prototypes with them to actually deploying practical production-grade implementations of use cases. Very short span of time, like 3 to 4 years, as I mentioned. Meanwhile, there are also database systems that are being enhanced with blockchain-like features, to avoid tampering and all that, or even if tampering itself cannot be prevented completely, at least if some data has been tampered with, you can detect the fact that it's been tampered with. There are lots of Chinese software companies that are also extremely active. In terms of what's going on, I'll just skip through certain slides just to tell you that in Europe, there's a group of countries that have gotten together as part of the European Union, and they've set up something called the Blockchain Observatory and Forum, and they have produced lots of research reports and addressed various aspects of use cases that you need to think about, how to combine blockchain with AI and IoT, framework for blockchains and smart contracts, legal framework. Also talking about GDPR, on and on. Healthcare space doing something, or cybersecurity, and what role blockchain has to play in such environments. You'll also find lots of reports and videos of the research priorities and the social impact of blockchains. Even in Tamil Nadu, the Tamil Nadu e-governance agency, for which I'm an advisor, is talking about creating a Tamil Nadu-wide blockchain backbone, which the TNE will support and enhance and so on, which can then be used by different departments of the Tamil Nadu government as well as private organizations to implement solutions. There are many such things going on in Europe. There is a European blockchain partnership. They're also currently and building a European blockchain infrastructure, which is similar to the blockchain backbone that I talked about in the context of Tamil Nadu. And there is also this public-private partnership with the International Association of Trusted Blockchain Applications. Some of these sorts of organizations, people came and spoke at the conference that was held a few months ago, where I also spoke, which was by the Election Commission of India, jointly with the Tamil Nadu e-governance agency, trying to see how in India blockchains can be used to permit a person who is currently working in one part of the country, but whose home base is in a different state, to be able to remote for people in this constituency. So somebody who's a Bihari who has the right in Bihar is currently working in Tamil Nadu, and that person being able to go to a polling booth in Tamil Nadu and cast votes for candidates in his home constituency in Bihar, that sort of thing. As I said, in the last few years, dramatic progress has been made. And lots of work in this space gets done in the form of consortia instead of individual companies producing products, or as in the case of NoSQL, 3 or 4 people across the globe will get together and they'll produce a new NoSQL system and then throw it there on the on GitHub or something. There was too much of that kind of chaotic way of doing things that has been the norm with big data systems and NoSQL systems, whereas in the case of the permission blockchains, it's been more the groups of organizations getting together, commercial as well as non-commercial organizations, and creating systems in an open source way, typically. But of course, there are still, offerings that are managed offerings that are produced by commercial entities where they charge you for making use of such managed offerings. But if you want, you can still download the code and run it in your own systems and so on, if you don't want to pay money. Obviously, there are some additional functions that offerings provide that are not necessarily in the open source version. So this just shows you the, across the world, the breadth of coverage by different organizations, and how Amazon, for example, announced this QLDB, which is a very special purpose single node database system. It is not doing multi-organizational blockchain applications like what I mentioned before, but this is within an organization in a more systematic way, recording what transactions happen and which departments of the organization took part in executing a transaction and so on. This could be in the context of how loan application gets processed, or an accident insurance claim gets processed, where different departments might deal with different aspects of the claim. One deals with personal injury, the other one deals with property damage and things like that. And the Chinese president, for instance, about a year ago, said there'll be a national focus on blockchain. So certain countries have taken this extremely seriously. Certain other countries are still kicking their tires. And so there's wide variation across the with respect to how much of activity is going on in the blockchain space. There is also attempts now, in the absence of mature standards, trying to allow for interoperability, where in a single use case, you might make use of multiple blockchain systems which are different in terms of their API and so on. This is like heterogeneous data integration. In a traditional database application, you might make use of for certain data DB2 and for certain other data Oracle and for some other data SQL Server, and how you execute transactions that span these different systems. Similar things are being done. Just like you have port applications in traditional database systems where if you use the standard, you could more easily port an application from DB2 to Oracle. There are attempts being made through this thing called DAML to have portable smart contracts and be able to write the smart contract once and execute it on different systems. Clearly, in the absence of APIs being the same and so on, this is not an easy thing to accomplish. So this is still work in progress. There is also a benchmarking group that's been formed under the Hyperledger Consortium. It's called the Caliper Project that's doing certain things. This shows that there are vendors out there that are providing support for Hyperledger Fabric. They might also support some other blockchain systems like Quorum and Sawtooth, but they all support definitely Fabric. There are also lots of research projects now across the globe which have chosen to focus, if they are focusing on permission blockchains, on Fabric than the others. So in that sense, also there's greater momentum behind it. Standardization is still in a very immature state. I'll let you go this links here and look at what's going on. Very recently, an event was held joining forces for blockchain standardization. They looked at certain aspects of blockchain systems and wondering about those things. Here I have lots of complaints. I won't dwell on them. I'll let you go look at my video from last year's SIGMOD conference in Amsterdam, where I talked a lot about some of these things. As I said, there's a lot of hype associated with permissionless ones compared, and people will claim that permission because some people control it and so on. This is no different from, if you want to be a supplier to Apple or IBM, you have to undergo their stringent qualification criteria. So you shouldn't be surprised about such things. Governments also want to know you're not doing anything illegal. So money transfer and all that being done in a, anonymous way is not good to prevent terrorism and such things. So for a variety of reasons, some of the claims that are made in favor of permissionless are bogus, actually. And there are lots of complaints that people have had about why cryptocurrencies are bad. This Nobel laureate in economics has said this notion of cryptocurrency has set the world back by 300 years because it's not like individual kingdoms, the Chera kingdom, Chola kingdom, and so on in India had their own currency. There was a good reason why the world evolved to countries having common currency. And in Europe, even multiple countries got together and created this new thing called euro. Now, for suddenly a group of people to think that they should have their own currency is in many ways giantly backwards in time, not really progress. And there's also all sorts of shady things that have gone on. When somebody steals your cryptocurrency, you can't go complain to anyone if that cryptocurrency was based on permissionless network. Even know who the real world people are behind these identities. So the US government, after being wishy-washy about cryptocurrencies, then started saying that they are going to treat them like traditional assets. So in the case of the Commodities and Futures Trading Commission, they said they're going to treat cryptocurrency like wheat and oil and such things. The Financial Crimes Enforcement Network said we're going to treat it like traditional fiat currency. The SEC, the Securities and Exchange Commission, said, guess what? Except for Bitcoin and Ether, all other cryptocurrencies, just like security means it's like stocks and so on. The IRS, the Internal Revenue Service of the US, said they're going to treat it like property, just like home and car and such things. So essentially, they wanted to bring it under the ambit of traditional ways of accounting having to be done, taxes having to be paid, and such. Then you have all these bizarre things like people say, oh, with completely peer way in which permissionless networks operate, we don't need centralized entities like banks and such. But in fact, people decided, oh, if I lose my private key, I lose all the money that's in my wallet. So I don't want to get into that kind of a situation. So I'm going to actually use an exchange to keep my crypto assets. Guess what? That's a for a bank. Exchange goes down, you lose all. So much for these things being completely distributed and so on, as many of you will hear in the next 5 days about why many people will come and tell you currencies are good and permissionless is good. There are also bugs. It's not like these are foolproof. And so if when there are bugs and people misuse the bugs to make money, if you want to go after them, make the money that they made illegally, for that reason also it's important notion of identity and authorization, authentication, and all that be there. I won't get into the details of Bitcoin, but essentially it does extremely simple stuff. It just deals with A wanting to send to B Bitcoins. That's it. And they try to do that in a way where people don't cheat each other and all that. But it doesn't even deal with the concept of why is it that A wants to send money to B? Presumably because B did something for A, sold some goods or services, and in return for that, A wants to send money. But they don't even model that goods and services that B provided to A as part of the business process. Also trying to make sure A pays B only if B did a satisfactory job. And that job might involve not just, sending some goods, but making sure over time the sent actually supposed to do, doesn't break too soon and things like that. All of that is not modeled at all. So in my opinion, this is also a very restricted notion of about. The way they do that and all, I'll let somebody else give you the details. They essentially make use of private key, public key, and an address. And that's what, and then they make use of something called the UTXO model, which essentially is a way in which these crypto assets are represented and how a transaction takes certain crypto assets that are in its input states and transforms them to output states. So it's possible that A takes some money that is in its wallet and sends it to B, but only a subset of the money. And the rest of it might send to somebody else or continue to keep it in its own wallet. So the way this whole thing works, it's like for people who might be aware of traditional workflow systems, they used to model them using, I'm forgetting the name now. Does anyone remember? These are networks which have nodes and tokens, and distributed simulations also work that way. Petri nets. Petri nets were used to model workflow management systems. This is like a variation on the Petri net model. The Bitcoin guys didn't create the whole thing from scratch. They actually combined a bunch of ideas. Merkle trees started out way back in 1980. They combined many ideas from those things. Even I worked on Byzantine agreement protocols way back in the beginning of my job at IBM in 1982, 83 kind of time frame. And then they cooked up this notion of a blockchain data structure. So when in 2008, the Bitcoin paper came out, it was a combination of many old ideas with some new ideas being thrown in. And even the notion of smart contract was actually proposed by Szabo back in 94 or some such time over here. Okay, I'll let you go look at this paper that was written by Arvind Narayan and Jeremy Clark, which gives you the history of how various ideas that emanated from different people got combined in order to create the notion of digital currency and the Bitcoin network and so on. There are lots of ideas from distributed systems as well as database systems which have a role to play. In the case of blockchain systems, in particular, the things that are in red have even more relevance in the context of blockchain systems. I myself have worked on workflow systems and many of the things that are mentioned here. But it's this combination of lots of sub-disciplines within distributed systems and database systems, and the modern day things like cloud and data privacy and all this, data flow restrictions, OLTP versus OLAP, and data warehousing and online transaction processing and all that, even stored procedures and so on, that all have a bearing on this systems. So in a broad sense, a blockchain system has three aspects to it. The consensus layer, which has to do with how these blocks of transactions get formed and how you collect transactions and create new blocks of transactions, how these blocks get connected to one another, who has the privilege of being allowed to add new blocks of transactions. That is governed by something called a consensus layer. And there are various algorithms that have a role to play in how consensus is arrived at as to who gets to add new block of transactions and what conditions must be true for that to be possible. And there is proof of work and proof of stake and proof of asset and so on. You'll hear lots of things about that. Then there is the environment in which the smart contract executes, whether it's a virtual machine or a Docker container and things like that, and also the language in which these smart contracts are written and what restrictions are placed with respect to what constructs you can use. Even if you're allowed to use Java, are all primitives of Java allowed to be used, or there are restrictions placed? Because the same smart contract in the course of executing a transaction might get executed in multiple nodes, and you want their results to be the same. And that also means certain primitives will not be allowed. Invoking a random function will not be allowed, and so on. There are certain systems which have come up with their own language, like Ethereum has its own language for writing smart contracts. And then you have the data model layer, which has to do with where the states of the assets that you are managing kept persistently. These could be database systems like relational database systems, or it could be more primitive systems like NoSQL or a document management system like Couch Database and so on. And these different systems that are around differ with respect to what choices they made with respect to these three broad set of architectural aspects of these systems, as well as there are many other aspects. Do they deal with only node failure, link failure, and disk failures, or do they also deal with individual nodes misbehaving, where I might tell Bhargavi, my name is Mohan, but I tell Asha, my name is Chandrasekharan. So I'm lying with respect to a certain fact. I give one information to one person, I give a conflicting information about the same fact to another person. This is called Byzantine behavior. Some systems don't deal with Byzantine behavior because, as I said, in permission networks, it's not such a big problem because people will worry about their reputation and so on. So if they do bad things, they will soon be discovered to have done bad things, and then they'll get kicked out of the system. So people don't want to, lose their privileges. This is like taking a loan and not paying the interest every month. After a while, you will be taken to court and things like that, right? So there are many aspects to these blockchain systems where different systems have made different choices with respect to the architectural features and so on. So there are also survey papers which go into how these different systems differ and things like that. There are similarities between the blockchain data structure that I mentioned, which is this thing on the top, right? This one, which is managed using certain concepts that I'm not getting into in detail, and so on, to detect how some block that was originally written with certain content has been tampered with, or you added a new block in between two blocks that previously were neighboring blocks. You had n and n plus 1. Somebody brought in between the two a new block, totally new block. Such things are easily detected using hashing and all that. The recovery that's inside a database system looks pretty similar to the blockchain data structure. But in the traditional way in which I worked on recovery logs and so on, we didn't worry as much about somebody intentionally tampering with these things, because traditionally, in computers, people didn't worry about, as in the modern days, hacking and so on, because traditionally, when you use mainframes and such, only trusted people were allowed to do things in such systems. Whereas with the web and all that, now it's become a lot easier with apps and such also coming into the picture. It's become a lot easier for random people to get into systems and things have had to be tightened with antivirus and various other things, right? Certifications and so on. So in that sense, the blockchain data structure has more tamper-proof kind of enhancements that it includes, which the recovery log didn't have. And also the order in which transactions information gets included and the actual content of the log records is also different. Okay, so for some people about database systems, these simply make sense. Also, if I remember, I talked about in the blockchain system how there is replicated versions of the single source of truth, right? The same piece of data gets maintained in all the nodes and they are updated in a systematic way. This is similar in flavor but different from how in traditional database systems, distributed database systems with replicas, the replicas get updated. And I won't go into the details because it's fairly involved, and if you don't have the right background, this may not make much sense. But we have these notions like log replay in order to have a primary copy and then a backup copy that gets updated as the changes first get done in the primary copy. And there are various approaches that are used when you have heterogeneous systems. You are first doing updates in Oracle and then you are replicating the changes to DB2. How you do that is very different from when you are doing DB2 to DB2 replication, for instance, and so on. So in the blockchain way of doing it, it's even more involved. So this shows you how, in the case of Hyperledger Fabric, from version 1 of that system, they started doing things like the following, where you, the top one is representing typically the permissionless networks, where the transactions that are submitted to the network first get ordered, and then they get executed, and then the database states are changed. In this case, since all the nodes that are participants in the network execute these transactions in parallel without talking to one another after they have been initially ordered, they all have to produce the same result. Otherwise, the different nodes will have database states which differ from one another. Whereas in Hyperledger Fabric, which is at the bottom, there is an initial phase in which a simulation is done of the different transactions that are submitted for execution, where only a subset of the nodes get involved in the simulation. These are the so-called endorsing nodes, and that's based on transaction type and all that as to which transactions get involved in the simulation of which transactions and so on. And then based on the simulation, not the actual execution of the transactions. Based on certain conditions being satisfied, these transactions get ordered. And then you don't anymore re-execute the transaction, but you validate the transactions. If the conditions are still the same as the conditions that were true when simulation was done, then during validation, the transactions for which conditions are still the same will actually have their updates incorporated in the database. But if the conditions have changed, then you will roll back or not incorporate those transactions changes. That means those loser transactions. Because of this variation not introduced in version 1 of Fabric, it's okay deterministic constructs in the smart contracts because they will be taken care of at the end of the simulation phase. Because during validation and the incorporation of the updates, smart contracts are not executed. Whereas here, the smart contracts are executed at this step. So this now goes into the details of how, in Hyperledger Fabric, transactions get executed, which I sort of in a hand wavy described. During the simulation, you execute actions but don't put the updates into the database. The read calls are executed in the database system, and then the smart contract will consume that data and produce some results, which are the put and delete calls. But those changes are not put into the database at that point. They result in what are called read sets and write sets being produced. So the same transaction gets submitted to two endorsing peers. They simulate the transaction execution.
Sir, we are unable to hear you.
Take the read set information, look into the database, and see whether items that were read are still in the same state. If they are, that means validation is succeeded. And then you will take the updates that are in the right set and you will put them into the database. If anything has changed that invalidates the read sets, the values are different, say that transaction is a loser and none of its updates will be incorporated in the database. It is this stylized way of doing things that makes the execution a much longer one, more expensive, but it has the good property that it allows for a transaction's execution to go forward or not being decided by multiple nodes, which are the endorsing peers. This is like the priest asking the bride and the groom, are you willing to marry the other person? And only if both parties agree, then the priest says, this marriage is now legal. It's agreed upon and so on. So it's this way of executing transactions that's very different compared to traditional transaction processing systems. That is the added benefit. And hence, people cannot say, hey, you didn't get my agreement before you did this, and hence I'm not going to honor the commitment that was made on my behalf by somebody else. And the way you endorse also includes your digital signature and so on, which is also a way in which you cannot later on claim you didn't agree to something and things like that. So those are certain aspects of doing things here that are very different. There are all sorts of comparisons I can make about how this is very different from traditional database way of doing things. And also, depending on the primitives that you are allowed to use in your smart contract, if it's only get, put, delete, which is essentially a key value store kind of notion, if the database system is a more sophisticated database system, like a relational database system, then these calls will be replaced with SQL select, insert, update, delete, and a call, a stored procedure, and so on, which will be a lot more powerful ways of modeling the assets, diamonds and such. If you want to model, it's a lot more flexible to think of the smart contract as a SQL application. We are all used to SQL applications being so much richer in terms of its functionality to model the assets, and also having functionality like referential integrity and triggers and so on, which stored procedures, which you can't have with these dumb key value stores. And so I am in favor for that reason as the persistent store in blockchain systems, relational databases rather than these modern day, but in my opinion, very crippled systems with very of transactions that are the what do you call it, no sequence and so on. So how are we doing with time? Oh, it's almost time, huh? Okay, let me quickly show you what the different applications are. They're all over the space. They're not by any means restricted to only financial industry. There's distributed energy, there is healthcare, insurance. There are many of these blockchain systems that companies work on. Some people work on even specialized hardware, especially in the context of permissionless blockchains. But there are also different companies that work on different kinds of use cases. There are also, ways in which, by making use of a blockchain, you can more easily track the transactions that or business cases in which even small vendors are able to participate. So small players, by being able to see the transactions that they are engaged in with various people, various organizations, will allow you to more reliably finance small and medium organizations, and thereby improve livelihoods and make more people get jobs and so on, rather than being dependent only on large enterprises. So supply chain finance can be done in much better ways with small and medium enterprises if they are made to be part of blockchain way of doing their transactions, because then more information is available to the banks and other lending agencies to be able to have more reliable information that they can base their decisions on. Food, when it gets transported, also can be better tracked with blockchains. So Walmart, for instance, has made use of this to be able to minimize the amount of recalls that you have to do if some food ingredient has a problem. For instance, the traditional way of managing all this, if you picked up an item in a store, a box of broccoli, it took you 6 days to figure out where that broccoli came from. Okay, whereas by recording everything that happens in the whole supply chain on a blockchain and making all the participants be part of that blockchain network, they're able to now tell you when you pick up, I don't know, it's mango, I guess, in a store, you can within 2.2 seconds find out where that mango came from. And this allows for all sorts of other optimizations to be done. So it's a much more systematic way of recording information. In Dubai, the government is trying to eliminate paper-based way of doing interactions between the UAE citizens and the Dubai government, for instance. Not all use cases are well done using blockchains because they have performance penalties that might not be appropriate if you want high transaction rates, or you are not necessarily dealing with organizations that are not trustworthy and things like that, or it's not involving too many organizations, or everything is happening within one organization. So there are such flowcharts that are made available for you to look at different aspects of your use case in order to decide whether you should implement them using blockchain or traditional ways of doing it. Even when you use blockchains, it's not like you throw away existing ways of doing things. You might still have coexistence between the blockchain way of doing things as well as the traditional ways. For instance, in this case, you might accept an order to make something through the blockchain way of interacting with other people, but in order to produce the accepted order, you might still make use of backend systems like SAP and so on. And so an order coming into the blockchain network might trigger the production of the corresponding goods in the backend system. And then once that goods is produced, it might then trigger the blockchain system to say that goods has been produced and now it can be sent around using the blockchain. When you have physical goods like diamonds and so on, you also need to worry about how to make sure the legitimate thing is not replaced with a fake thing. So IBM came up with something called a crypto anchor verifier that allows you to do that by encoding certain unique identities that relate to some physical properties of the item, whether it's a diamond or a capsule or cotton or liquid like high-priced wine or olive oil. This attachment to a cell phone, which is a microscopic lens, can see certain patterns that can then be recorded in the blockchain. And so if somebody does a substitution by replacing the genuine thing with a fake one, then when you remeasure on the fake one that same thing, same physical measurement, the value will be different from what the blockchain says it should be. Over time, from Bitcoin came Ethereum. From that, then came Enterprise Ethereum. There are various people that have worked on how to create a permissioned version of Ethereum. And one of them was done by JP Morgan called Quorum, which does things very differently. More recently, Quorum has been acquired by Consensus, which has produced another implementation of Enterprise Ethereum. And they are now trying to combine the two, the Go-based Quorum with the Java-based Hyperledger Besu, which Consensus was behind. There is also evolution of Fabric that I said was originally developed by IBM, and then in the form of the Hyperledger Consortium, it's been subsequently developed as an open source project with many participants from across. Libra is this currency that Facebook guys came up with, and the network that they formed around it has run into lots of difficulties with the government authorities in the US. It's a combination of permissionless and permissioned. The core network will be consisting of members of the Libra Association, and their identities are all known. But the people who submit transactions, the leaf nodes, are the you and I kind of individuals who are anonymous. But because of the difficulty that they were facing in the acceptance of their cryptocurrency, they have more recently said that they'll support fiat currency also, like the US dollar and so on. It's still in an experimental stage. Based on a group of banking kind of institutions, financial institutions forming a consortium, the R3 Alliance came up with something called Corda. Because of the nature of these participants, they hardwired into the conceptual model of R3 Corda certain concepts that are very specific to the financial industry, things like cash contract, bond contract, and so on. And this is what I meant by saying these different systems differ not only at the API level, but even at the conceptual model level. They even have the notion of notary and such. These notions are not in the guts of Fabric, for instance. Fabric is a very simple model at its core, but it has components which are replaceable. So it was more of a plug-and-play model. with no cryptocurrency as part of the base model itself. The Ant Financial guys have come up with their own thing called Ant Chain, and it executes in the Intel environment by making use of the trusted execution environment. So there they have this concept that certain piece of data can be shared by everybody within a network, but certain other pieces of data should be shared only with a subset of the members of that network. And so they talk about encrypting the data and also even the smart contracts. Certain smart contracts are public within that network, but certain other smart contracts are private to a subset of the nodes. So they need to be executed in a way where nobody can see exactly what's going on once the smart contracts have been agreed upon amongst the subset of the participants. So they make use of this trusted execution environment, also called SGX in Intel, where even the operators of the network cannot see exactly what data is being produced and so on, because it's all done in a very careful way. So Intel also initiated a project called Sawtooth under the Hyperledger umbrella. So I'm just giving you a feel for what's going on, not exact details, right? There's so much more material that needs to be covered if I were to give all the details. SAP has come up with its own high-level model, and they say, just like with SAP R3, they have certain concepts in their BAPL or whatever that language is that they came up with over there. If you code using that language, then they'll let you choose the backend database system, Oracle, DB2, SQL Server, and so on. They'll map from your BAPL primitives to the backend database system SQL constructs. In a similar way, in this blockchain environment, they've come up with certain primitives. And if you code your smart contracts using the APIs, then they will translate from their own APIs to the API supported by the backend blockchain system. And at this point, they support Hyperledger Fabric and multi-chain, but in the future, they think they'll support more. The idea being that you can change your mind about using Fabric at one time to later switching to multi-chain without your application having to change, because these guys will do the work for you because you are coding to their common API. A lot of this is dependent on how much you SAP to do the right thing, and how long they are going to be around in the business and so on. Smart contracts themselves, I said, this is one example of a portable smart contract, if you like, but in a more standards way, non-single organization way, DAML is the one that's being currently worked on in the Hyperledger Consortium. And at this point, it's intended to support Besu, Fabric, and Sawtooth. Cactus is another one that allows you to, and it's still an experimental one, have a single transaction, Hyperledger, a single blockchain transaction that can run across different blockchain systems, where portions of the transaction execute in these different systems. Caliper is the benchmarking framework that is being developed, and some tools in the context of the Hyperledger Consortium. This is the project I was working on, but it's not yet completed, where I wanted to replace the get, put, delete APIs that the Fabric is currently supporting with something more sophisticated, which will be SQL way of doing it with the relational DBMS underneath. I was working with DB2 as the underlying DBMS. There are lots of topics where a lot more work can be done. This is just a simple list. There's many more topics in which one can do work on. Similar in flavor to all the enhancements that have been done to relational since the mid-80s, when the first set of products came, to now, how lots and lots of new features, also new tools, new vendors who developed only tools, BMC and Platinum and so on, and also methodologies for making it easier for you as the database designer to figure out when to have indexes, what kind of indexes, and so on, how to partition the data and things like that. That's it. These are some links that you can go to get more information. And as I enhance my presentations, I post them in these different places and such. So I think I'll stop here, and it's, I guess, already very late. So I don't know if you want to permit any more questions, or it's
We
already
have
15 minutes.
we
Yeah, go
have
ahead, please.
4 questions. I think can I
Okay.
do it, right? Shall I read out the questions, sir?
Yeah, sure.
Is blockchain way of transaction more transparent than the traditional method?
Yes, but that has its price also, right? In the permissionless network, everybody can see what these transactions are, which is counter to the whole philosophy of information hiding and need to know and all that, especially with GDPR and all that coming into the picture. So that's another reason I didn't dwell on that point in the initial slide where I talked about permission versus permissionless. Transparency for certain things is good, accountability and so on, but for certain other things is not good, in the sense of I don't want to give away my competitive advantage by letting my competitor being able to look at what kind of transactions are coming to me, who is buying what products from me in what quantities and so on, right? So it has to be carefully handled as to what degree of transparency is good and what is not good from the perspective of organizations wanting to preserve their trade secrets and things like that, or competitive advantage. Okay. Next question.
Next question is from Shinzi. Okay, the previous question was from Nisha. Ms. Nisha. Okay, this is, could you suggest blockchain platform for healthcare system?
Well, I mean, all of these things are being used actually. So there are people, I mean, for instance, IBM worked with the US Food Administration as well as CDC, the Center for Disease Control, on prototypes. There are many use cases that are around. So I suggest that you look at that Sigmod paper of mine. There are universities also where people, my friend at Emory University in Atlanta, Li Jiang, she has worked on projects which are in the healthcare space, and there are many others. So I don't want to say that any one other system for healthcare per se, but clearly in the healthcare space, you do want to make use of permission network because HIPAA regulations and all that in the US and equivalent ones in some of the other countries, especially in Europe where privacy is very important, you do want to be careful about who gets to see what information about health related aspects of individuals and so on. So it's really silly to make use of permissionless networks and let anybody and everybody look at people's health related information. Okay. Next,
The
please.
next question is from Mr. Murugan Kuppaswamy. Is it possible to get some light on polygraph technology, next version of blockchain?
Holograph. Is that what he has said?
Yeah, polygraph technology, the next version of blockchain.
I don't know what that is. I mean, or hash graph. There are some people who have talked about hash graph as one way of doing some of this, but I'm not sure what Murugan is referring to here. Sorry, I can't answer that one. He can ping me separately. He knows me. Next.
And the next question is from Ari Vajagan. How blockchain can help financial institutions in their lending process to small businesses? Can you give any specific examples comparing the present system and how it will be replaced with blockchain technology?
Well, so that's where I was referring to that SCF, supply chain finance, where I was referring to the fact that by exposing more of who these small players are doing business with, and even permitting as each transaction is done, meaning they supply something to somebody and that somebody then, even a portion of the payment could be directly sent to the lending institution. So thereby you can increase the trust level of the lending institution with respect to these smaller players who don't have enough of a track record or name recognition or credit history and all that for them to be trusted. So the reference I've got over there with how the Ant Financial guys have written a paper that goes into these sorts of details. In general, you'll find if you go into the full deck of my presentation, you will see some references, but also if you refer to my paper from last year's SIGMOD, you will see some references. But in general, you can actually Google some of these sorts of things and find lots and lots of work being talked about, which has to do with enabling little players to be participants in processes more easily. What they are doing can, in that sense that transparency was referred to in the first question, become transparent to selected people, namely these lending institutions and such. And as a consequence, the lending institution doesn't have to directly get the information only from the small player, but it can also rely on the small players' communications with their supply partners and thereby build up their own information about what's going on. I hope that was somewhat clear. Okay.
So the next question, two participants have almost asked the same question. Ms. Sweetline Priya and Ms. Purnima Girish, could you please highlight a few applications and use cases of blockchain in education field, education sector?
Okay, sure. There are lots of places where people are now talking about, for instance, universities and such, any kind of educational institution, putting the certificates, I mean, like degree certificates and so on, online. Not online per se, but putting it in a blockchain. So let's say you apply for a job, instead of the organization that you applied to having to rely on your resume's claims about what degree you have from which university and so on, they can actually directly check with that institution. In the traditional way of doing these things, it would have been more expensive, time consuming and all that for let's say IBM wanting to check whether in fact I got my PhD at University of Texas at Austin by having to communicate with UT Austin. Instead, they can now make some of these things be readily in a electronic way verifiable by putting them on blockchains, with of course still certain level of all that around it, right? And hence the need for identity and all that to be there. You don't want willy-nilly people able to do this. In this case, it might not be bad, but healthcare case, you want to permit only people who you specifically authorize to be able to look at your, diabetic condition or this or that, heart problem or AIDS or whatever that you might have. So there are many such things that are going on where how you prove that you got a certain certificate, I don't know, senior architect kind of certificate from some certificate granting institution. So there are things like that that are being done. So it's all a question of being able to get at information in a way where you're able to trust that it came from the person or organization that you claimed it came from. And that's where leveraging things like private key, public key, and all these notions makes it possible, with identity and all that being part of the mix. Okay.
So we have one last question.
Yeah.
From Mr. Amitoj Singh. How can we differentiate among blockchain, hashgraph, and IoT?
Okay. See, IoT, you said IoT, right? Internet of Things?
IoT.
Oh, IOC. I don't know what that is. Where are these things? Can I see them? Are they in the chat or they are somewhere else?
Yes, it is in the chat box.
Chat box. Oh, IOTA. What is it? What exactly is that? Can you type the full form of it? IOTA. I can't throw light on polygraph. I don't know what that is, Murugan. I don't know what IOTA is also. IOTA has re-engineered the principles of existing distributed electrical. I don't know about IOTA. I would have to go look into that. I see he has given the expanded. He has given a link, so I have to go look at it. In general, there are different people working on these sorts of. Performance is not the only thing. It's also a question of availability of people to, skills availability. For example, a lot of people are using Ethereum not because that's the right thing to use, because since Ethereum has existed for a while now, there are a lot of people who know how to code smart contracts in the language that Ethereum supports. And hence they begin to use it, whether or not it's the appropriate platform to use, because there aren't enough people that, comparatively speaking, that know how to write Go programs, which is what initially Hyperledger Fabric was supporting. Now, of course, Java is being supported. So certain times people do misuse certain tools for purposes that they were not originally intended for. Just because I know how to use Oracle, I shouldn't keep using Oracle for every bloody database application, because it might not be the one that fits the bill when it comes to requirements and so on. So it's in that sense also, I find it very problematic that way too many people get sucked into adopting something just because it might be good for one use case, but later on, if you want to now expand the scope of your application to include certain other aspects of that use case, if this system is not flexible enough, it only does one thing well, but not flexible enough, then it might be the wrong thing to have done. So it's in that sense also, yeah, there are people coming up with all sorts of variations on some of these sorts of ideas that have been around for a bit, but you need to treat these things very carefully. It's no different from using, one NoSQL system for a purpose for which it wasn't originally designed. So generality and specificity have their pluses and minuses. There's always this talk in the database community about one size doesn't fit all. So people said after a while, oh, DB2 and Oracle and Sybase and so on, they were developed eons ago. So we should now go with these NoSQL systems because they are tailored for a specific thing with performance in mind and blah, blah, blah. But after a while, as your requirements change, if these systems that were so narrowly focused are going to be extended, they might not work anymore as well as they were claimed to work for a very narrow use case. They don't handle, generalized notion of transaction, for example. So in that same sense, you also have to think about in this context, whether or not some of the new things that keep coming up every other day should be given as much prominence as the more broad-based set of criteria that you use in order to go with a certain system. Oh, in blockchain implementations, just like people, the last question I'm addressing now, just like in a database system context, you have application programmer, you have database administrator, you have systems administrator. In the case of blockchains, you can be the person who does only the management of the network, doing performance measurements and so on. You could be the person who does the client-side application implementation, which is dealing with GUI and such things, submitting transactions and such. You could be the person architecting the whole network, defining who the participants are, what the assets are that you're going to manage, what the transactions are that will be supported, who needs to agree on a particular transaction to go forward with, which of the nodes will be Ledger Fabric, the endorsers. And just like you have in a database system, the roles that people play while executing transactions could also be like, this person can only execute transactions that involve less than $1 million, whereas this other person can do things greater than $1 million and so on. So there are various aspects that go with the sort of the end user kind of people versus the people who are part of the network itself that are doing performance measurements, that are dealing with failures and so on. So in one of the slides, I have some of this kind of information that I didn't show, okay? I don't want other people getting mad at me, so I can keep going for a while, but you have an opening ceremony or something that was supposed to happen half an hour ago, right?
Yes, sir, it's already started, the AICT, and our heads have already joined the link there. So I think that is the last question, sir. We have no more questions.
Okay, thank you so much. So, and I actually asked at one point whether you turned on the recording, but then you did do recorded. It before. Okay, yeah, wonderful. So do send me a link to the recording, and sure. I will now stop. What should I do? I don't have to do anything, I guess. You can now get going, right? Okay, thank you. Sure. I might sit around for a few minutes, but I have to go have my dinner. It's already 10 o'clock for me. I haven't had my dinner. Thank you, Bhargavi, and thanks to Asha and also your principal. Okay, thank you so much. I didn't specifically.
Yeah, with this, I thank Dr. C. Mohan for an enlightening keynote address on state of permissionless and permission blockchain, myths and reality. Through his knowledge-enriching talk, Dr. Mohan C. has enlightened us with the overall perspectives of blockchain technology. I once again thank you, sir, for accepting our invitation and joining us from across the USA and sparing your valuable time with us. Thank you so much.
Sure. Bye-bye. Take care, and all the best for the function. I mean, the whole course for the next 5 days. Bye-bye. Take care.
Thank you, sir. Thank you.
Yeah.